What is the biggest mistake the medical industry is making when treating cancer?
Well, that's kind of a broad question. They're not making one mistake. They're making many mistakes. The consequences of that are over 1,700 people a day in the United States dying from cancer, over 618,000 people a year. By the time you and I are finished with this discussion, 70 people in the United States will be dead. And also, when we magnify that around the world, you're talking an enormous amount of people that are leaving the planet. Cancer is a disorder of energy metabolism, mitochondrial dysfunction, where the field throughout the world seems to think that cancer is a genetic disease. So they're spending enormous amounts of money and approaches either hunting for genes or trying to target genes for a disease that's ultimately not genetic.
Yeah, okay, so I want to get into how to manage it and everything like that.
If the tumor cell cannot survive with simple metabolites like the sugar glucose and the amino acid glutamine, and the tumor cells are incapable of transitioning away from those two fuels to fatty acids and ketone bodies, the logical strategy would be to deprive those cells, that tumor in a person, of those two fuels, while transitioning their body over to a state of nutritional ketosis. We don't ever use the term cure. We use the term management because we don't know if anyone is cured. All we know is they live longer with a higher quality of life. And that doesn't mean we can't use radiation or toxic poisons. They would be used in very low doses at strategic times when the tumor cells are massively compromised energetically, being just barely hanging on for survival. A small dose of a toxic poison could be considered, just like a small dose of radiation and a surgical procedure to remove whatever residual mass might be there.
Yeah.
So you'd have to redesign how we use some of the strategies. Right now, people are all excited about immunotherapies. Immunotherapies are, again, based on the genetic basis of tumors. You're trying to target tumor cells, but the epitopes or the targets are massive in great number, and they're always concerned that the tumor's acidification prevents the immunotherapy from working. Where does the acidification come from? It comes from the sugar glucose and the amino acid glutamine. If you get rid of them, the tumors become extremely vulnerable to a large number of what we're already doing, especially if the patient is in nutritional ketosis. I mean, we have so many unique ways of killing cancer cells without causing any toxicity to the patient.
Yeah.
And we publish these papers in top journals. We have case reports showing the therapeutic efficacy, but it's pretty much ignored.
And why do you think is that? Do you think that there's something intentional? Or?
No, it's not intentional.
It's ignorance.
A lack of knowledge, I think.
Yeah.
Well, it's also a desire to maintain the status quo.
Oh, yeah.
I think anytime you change a paradigm, I don't care what it is, there's a lot of a disconcerting feeling about this. I've been doing this the same way for decades, and I don't want to change. But, in the case of glioblastoma and some of the more deadly cancers, we haven't made any progress in 100 years. And yet they continue to do the same thing over and over again. Yeah. And most of the poor folks are dead within 5 years or less, even within a few months. So this is nuts. Yeah. And yet we have a clear path to providing a logical solution to this problem based on the science. The science is telling us to go this way. Yeah. But the field resists for a variety of different reasons. Yeah, well, I think so. I mean, all you have to do is see the advertisements. No one's talking about nutritional ketosis as the starter for making or having standards of care work. And that tells you that the system is very reluctant to change. Yeah. But I look at it as a humanitarian thing. These people are dying. I mean, these people are dying horrific, painful deaths. Either from the tumor or from the treatments that they're given.
And you think that the way to treat it is by making the public more knowledgeable of the things?
Well, I think the public should know that there is an approach. And we never say we have a cure for cancer, ever. We just say we have a strategy for managing cancer, improving overall survival and quality of life. We have some individuals that have been using metabolic therapy with terminal cancers for over 10 years, but the tumor is not gone. But they're not terminal either. So, but they've lived far, far longer with a higher quality of life than would have ever been imagined. Whether a person gets a cure or not, we don't know. But what we have is far better than what the strategies that we have. And as I said before, we don't throw out standards of care. We don't throw out immunotherapy or toxic radiation or poisonous chemicals, which they are. We just learn how to use them more strategically. Rather than as a beginning treatment, we use them as an end. In other words, when you have just a few residual tumor cells hanging on, a small dose of a toxic poison could possibly eliminate them, but it would be much lower dosage, and your body is already protected against the poison by being in nutritional ketosis. So we have a way to transition the whole body over. So the normal cells in the body get stronger and stronger and healthier. The tumor cells get weaker and weaker and closer to death. And thereby we can push them over the edge quite effectively by combining a variety of different tools. We have all the tools in the tool chest for effectively managing cancer today. We just have to learn how to use them in the appropriate way.
So first of all, can you give us a bit more statistics about the things that you see day to day in these treatments?
Well, we have papers that are published from people that have terminal cancer. And I mean terminal. I mean, we have the breast cancer woman from Ohio. We've published her paper in Curis. She was given 1 month to live. She had breast cancer. It metastasized to her bone, her brain, liver, and lung. She went to our colleague's clinic in Istanbul, Turkey, and received metabolic supported chemo, which is putting her into nutritional ketosis and using low doses of chemo. And she's out now over 5 years, and she's very healthy. And she was supposed to have only 1 month to live. People say, well, these are anecdotal.
Yeah,
they're published. I mean, what do you want? I put all the data in there, anecdote or not. I mean, glioblastoma, 10-year survival. Does it happen to everybody? No. But the fact is that you can get some of these people to do far better using metabolic approaches than you can using the standard of care. Should open the floodgates for people to come in. The first thing they should say, I want metabolic therapy for managing my cancer. And the physicians will say, what's that? And they say, well, I have to lower my glucose and elevate my ketones. Oh, no, you can eat whatever you want. Take as much carb. But this guy, these kinds of folks just don't know. They lack knowledge. They're not trained. But it's not their fault. Yeah. They have just been trained by a system that itself doesn't understand the nature of the problem. So it's a combination of failures up and down the whole spectrum. The patient doesn't know about the nature of the disease. The very person treating the patient has no clue about the nature of the disease. And the industry is not interested in knowing about the nature of the disease.
Seems like a vicious cycle.
It's really hard.
And it probably feels like an uphill battle for you.
All these major paradigm changes have always been uphill battles. Oh, yeah. The field just doesn't turn around a multi-billion-dollar industry and say, oh, we've been making a mistake.
Yeah, how much of it do you think is the financial side is playing?
Probably the financial side is the number one reason why we can't manage cancer effectively. Unless one can find out how to rechannel revenues. And not to say we're going to get rid of any. We can simply charge more for giving much less. I mean, if you want to do the most important thing is doing it the right way. Okay, and I don't think people would mind paying money if they knew that the outcome would be good. Right now, someone is diagnosed with cancer, and they have a terrible anxiety. They think the Grim Reaper is looking over their shoulder, waiting for them, and that doesn't have to happen. We're trying to put the Grim Reaper out of business, But they need to know what to do. Our metabolic therapy requires a tremendous input on the part of the patient. The patient must understand what they have, and the patient must understand what they need to do to bring their blood sugar down and their ketones up. And that's why we developed the glucose-ketone index calculator, which we published here at Boston College, which will be the tool by which we can manage cancer and all major chronic diseases as well.
Yeah.
Because we're putting people back into the period when we existed on the planet in the Paleolithic period, 400,000 or 500,000 years ago. All of our ancestors were in nutritional ketosis. There were no donut shops and delicatessens on the corners in the Paleolithic period. So they killed animals and ate them. Whatever they could find, they would eat. And they were always a low-carb diet, basically. So a lot of exercise, low-carb. These people, we know because those who live according to traditional ways rarely, if ever, have cancer. Scientists like humanitarians who have gone around the planet looking at people, rarely do they have cancer. What killed our ancestors was injuries and infections, not chronic disease, obesity, cardiovascular disease, cancer. Those things that rarely, if ever, existed.
Yeah, people might say for the argument against it is that they lived much shorter.
Yeah, but they were dying. They didn't have an osteopathic surgeon to fix their broken bone, nor did they have antibiotics to reduce the infection that they had. So if they had orthopedic surgeons and antibiotics, they would live very long, because you would eliminate the critical thing. As long as but the problem is our science and technology has evolved so much faster than our biology. We are still Paleolithic man living in a very toxic environment, highly processed carbohydrate foods, anxiety, poor sleep, all these things putting us at risk for cancer, cardiovascular disease, diabetes, obesity, all these kinds of things are the result of the new environment we're living in.
Can you please elaborate? A couple of things. So first of all, I do think that the way to maybe change the paradigm, believe it or not, maybe I'm optimistic, but I think it's through public knowledge, and this is why I do this.
Yeah, well, I think you're right. I mean, but again, you have people that will never care, but that's okay. We always have those kind.
Yeah, of course.
But I think the majority, if they knew what to do and how to do it, I think they would take their life in their own hands.
Yeah,
and that's why we developed this glucose-ketone index, because we have built a chart for this that will tell a person, and with their continuous glucose-ketone monitors, you can then look at your phone and be able to know at any given time of the day, we're working on this, what zone you're in with respect to risk. Are you in the zone of risk for cardiovascular disease, cancer, and dementia? Or are you in the management zone? Or are you in the prevention zone? Because we know that cancer involves mitochondrial dysfunction coupled to a substrate level phosphorylation, which is a fermentation. And as long as you can keep your mitochondria healthy, it's very hard to get cancer or any of these chronic diseases. So it's a mitochondrial centric issue here. And I don't know if enough people in the clinics know that the mitochondria is responsible for your ill health. Mitochondrial dysfunction. What gives you mitochondrial dysfunction? Lack of exercise, eating highly processed carbohydrates, being stressed out all the time, poor sleep, having no friends. All these kinds of things impact negatively on our physiology, causing the mitochondria to become damaged. And either those cells will drop out and die if they can't transition to an ancient fermentation mechanism, where they start to use glucose and glutamine fermentation to drive dysregulated cell growth, and then you get cancer. You could have diabetes, you can have all the chronic disease and dementia. We put them all into the same thing, all as the result of various types of mitochondrial dysfunction. So this whole thing we created this problem for ourselves. This is not something, it wasn't our genes that made it. We evolved to be very, very hardy and tough people. I mean, when you think of the hundreds of thousands of years we were eking out an existence, and then all of a sudden, within a few hundred years, we're thrown into an environment where abundance is overwhelming in the things that are actually unhealthy. And then we wonder why we have all these diseases. Give me a break. You need to understand evolutionary biology. And when you understand evolutionary biology, everything makes complete sense. We have an obesity epidemic, right? That obesity is evolution in action. We are starved species. We can go long periods of time without food because who knew when the next meal would come? Do you know how hard it is to kill a big buffalo or an elephant to get food? I mean, it's not easy. You're not going to go out and throw something in a microwave. It takes a lot of energy to kill a buffalo or an elephant.
Yeah, and it's a buffalo right now, and tomorrow it's rotting buffalo.
Yes, you do all that, and that's a lot of energy. You're using a lot of time to spend to do this. And the food is all natural. It's not it's organic, I guess you could say, but clearly it's would keep us healthy. Yeah. Then all of a sudden we developed all of these food science and technology, allowing food to be on a shelf for months. I mean, I have a Twinkie in my office. You know what a Twinkie is?
Of course, yeah.
Okay. It's 12 years old, and it looks brand new. And I had a mouse break in a couple of years ago through the wrapper, and he ate the Twinkie. He didn't seem to care that it was 12 years old. It was very tasty. So I mean, we're making foods that look normal and look healthy, and it's completely chemical. It's all chemicals. Then we wonder why we have dementia and obesity. So obesity, as I said, is evolution in action. We have genes in our body that are supremely designed to store energy because we were always going to be starving. So then you take those same powerful genes, and now you have this abundance of carbohydrates, and you get fat. I mean, this is evolution in action. We were not supposed to be. We didn't evolve to be fat. We evolved to be lean.
Yeah, it's a feature, not a bug.
Yeah. Yes. So whenever you see obese people, it's evolution in action. You don't know about biological evolution? Obesity is right there in your face. That tells you. Those are the people that are obese today were the survivors of great food restriction in the past, because the people that didn't have the genes to store energy died. Yeah. So the people that had the storing energy lived, and their offspring, we see them today. Yeah. And when people say obesity is a disease, it's not a disease. This is foolish. These are people who lack knowledge. They have no clue about evolutionary biology. So we're making it look like, they have some sort of an affliction. You know, it's their biology that's evolved over millions of years to say you are a survivor today because your ancestors could store energy. Whoa, if they couldn't, you wouldn't be fat today.
That's so fascinating.
Yes.
So the thing I think might help some of the people listening. You said that the Paleolithic world, the people were all on the ketogenic diet.
Well, I don't want to call it a ketogenic diet because people ate a lot of meat.
Yeah,
which is low in carbohydrate.
Oh.
So when you
just wanted to ask what it is.
It's a low carbohydrate diet. So you would be eating a tuber if you could find one, but they were all natural plants. You know, some berries, nuts, and animal products. As a matter of fact, there was a paper I think earlier this year out of Israel actually with cavemen. They were looking at bones and things what they were eating, and it was very interesting. This was Paleolithic time, even before Neolithic is when we started to cultivate grains about 10 or 12,000 years ago. So you talk 100,000 years ago. What were these guys eating? They were killing and eating large animals. But what was very fascinating about the story, the archaeological evidence, was they were killing and eating the strongest members of the herd. Apparently, our ancestors knew that the greatest amount of energy would come from eating the strongest animal in the herd, leading to lack of protection, causing the extinction by predators. So, if human beings are eating the strongest members of the herd or the group, that leaves the very young and the very old vulnerable to predatory activity, leading to the extinction. So man indirectly led to the extinction of several types of large animals because we ate the tough ones. So we obviously knew where the greatest amount of energy was coming from the marrow and from the meat of these strong animals, which would give us strength. But we put the rest of the species vulnerable to their natural predators, leading to extinction. So, we were a smart group of people, for sure. Yeah. We knew where to get the best food and how to get it.
It does seem reasonable, yeah.
Yeah, of course.
But how does the ketogenic diet, what it is, what it's doing to the metabolism?
Well, when you eat animal foods, if you're eating low carbohydrate, we don't like to use the word ketogenic diet.
Oh, so how do I?
Because you know why? In the medical profession, diet is ambiguous. People say, I'm on what diet? I'm going to eat this diet. What diet? We don't care. All you know is when you measure your blood sugar, your ratio of glucose to ketones, we look at it as nutritional ketosis. And we've defined the zones of therapeutic and nutritional ketosis. Some people could get into that diet eating fish. Some people can do eating meat, Mediterranean, as long as it's calorie restricted. It's a little harder on vegan diets because there's so little protein in there. You're like a farm animal chewing grain all day long. I know some vegetables, but it can happen. It's just a little bit more challenging. But I think carnivore diets, calorie restricted, Mediterranean, pescatarian. So it's not the diet; it's the zone you're in. So the GKI, which we have a major paper under review right now, will allow an individual to know what they can or cannot eat. So it can be religious, cultural, age-wise, sex-wise. You can eat any. You will always. Well, can I eat that or that? Eat it and see what happens. If your GKI goes up, don't eat that. If it goes down and puts you in the zone, then that looks like it's pretty good. As long as it's balanced for macro and micronutrients and generally restricted in calories, people, almost everybody can get into a state of nutritional ketosis.
And what's the benefits? And perhaps you can make it the difference between treating with keto or with low carb and everything for the cancer and dementia and everything, and for the common man or woman who wants to just benefit their life.
Well, I think now they have a tool. Now we have for the first time an actual quantitative measure. Because in the past, I'm doing keto. What's your GKI? I don't know. Well, how will you know you're doing keto? You don't know. So you measure, I guess I wasn't. So once they have the tool, they will know exactly where they are, what zone they are. So you can prevent, if you keep your mitochondria healthy if you're in a low GKI, glucose-ketone index ratio, your mitochondria are burning ketones. Ketones are a super fuel. We evolved to burn ketones. We keep the reactive oxygen species down. Every breath of air we take, we get more energy per breath of air if we're burning ketones than if we're burning carbohydrates. So clearly, our bodies tell us if we're healthy or not healthy. Our mitochondria tell us whether we're healthy and not healthy. And I think we've been overlooking the signs of our biology telling us what is good or not. We keep throwing pills and drugs and all kinds of stuff at these. This is nuts. I mean, you get the patient into a low GKI, you can still take those drugs or things, but you take very little of them. You don't have to take them as often, and you take them very little on this. So humans always want the quick fix. They always want something that you don't really have to spend a lot of time knowing about or doing. But that's their problem. As long as they have knowledge, they can look at the chart, see where they are any given day, and then they can make a conscious decision as to what zone they want to be in. You want to be in the high-risk cancer zone, dementia zone? Hey, that's your choice. But at least you know you're in that zone. And you know how to get out of that zone and get into another zone by simply measuring your blood sugar and ketones in real time. And that's coming. These tools are coming.
It sounds amazing. But I want to get into the way that people can measure themselves these days, and we'll get it in a second. But I want to go back to cancer and the way that the things that you suggest are treating it. But if you can please elaborate first on how much of a problem is cancer globally currently.
Well, I think it's a major problem. It doesn't seem to be going away. It only seems to be getting worse, which should never happen now that we know what to do and how to prevent it and how to manage it. But again, it's not consistent with the worldview of what it is. But I think in China, it already surpassed heart disease as the number one killer of Chinese people.
A word you can use.
I was there a couple of years ago, and I heard someone tell me from one of the Chinese statistics, they were 8,100 people a day were dying from cancer in China because they have a huge population. But it's all connected to chronic diseases. Cancer is being one of them, one of the major ones. And I think it's different than diabetes or cardiovascular disease. You have cardiovascular disease, you take some pill or something like this, or diabetes. But when you have cancer, you feel that you're going to suffer immensely, and there's no cure, there's no management, and you're eventually going to die. And if you happen to survive the poison treatments and the surgical mutilation and the radiation, if you happen to be so fortunate to survive all that, your body has been brutalized by these toxic situations where a tumor could reappear, either the same tumor or a completely different tumor some other place in your body, and come back at you in some other completely different way. We know from being exposed to poisonous chemicals and radiation and all this kind of stuff, people then suffer with survivor anxiety. They have hormonal imbalances, bone density issues, neuropsychiatric problems, digestive problems. All of these are the results of being poisoned and irradiated. So, I don't know anybody who wants radiation and poison to prevent themselves from getting cancer, right? You know anybody who does that? I mean, you might get a vaccine to prevent you from getting a virus or something, but you don't, today's my day. I have to go down to Dana-Farber or MD Anderson to get irradiated to prevent me from getting cancer or take this toxic drink. This is nuts. Yeah. So, but when you have cancer, they give you all that kind of stuff. It's like crazy. So, but no, I think that, yes, cancer is a major disease. I mean, the pharmaceutical companies are gearing up for a massive number of new cases by 2050. What's going on? We know how to drop those deaths. We know how to prevent it. We know how to keep people alive without doing that. And as I said, when you take people and you give them all these poisons, chemicals, and all this kind of stuff, you increase entropy, the second law of thermodynamics, which is disorder. Your mitochondria get brutalized by being irradiated and poisons. I mean, you're damaging the very organelle in the cells that you need to be healthy, right? When you're in nutritional ketosis, the mitochondria are getting super, super healthy. And the tumor cells now become marginalized because the fuels that they're needed, like glucose and glutamine, are being targeted. Yeah. And that's why we have to know how to do this, because we developed the press pulse therapeutic strategy where you can press glucose down real strong because you don't need it. We can switch to fatty acids and ketones. Tumors can't. So once they are put into this marginal zone, we come in strategically with glutamine targeting drugs. We're working on dosage timing and scheduling. So because the glutamine is so important for our immune system and our gut and just normal function in our body, we can't be too aggressive in targeting glutamine, the amino acid that's fermented by the tumor cells. So, but we can hold the glucose, and then we can come in and gradually degrade with the glutamine targeting drugs while the mitochondria and the rest of the body are getting super healthy. So all your normal cells are getting healthier and healthier and healthier, and the tumors are getting weaker and weaker and weaker. And eventually you end up in a zone where the tumor has been reduced to an indolent growth or an indolent state, or gone completely. We don't know. But it's certainly, and you feel much better. We've seen people who come in with hypertension, high blood pressure, prostate cancer, and diabetes, and we put them on metabolic therapy, and everything starts to go away. The hypertension, the high blood pressure, the diabetes, along with the cancer, because they're all the result of damage to mitochondrial dysfunction in one way or another. Wow. So we want to restore the power of our mitochondria, because that ultimately determines how long you're going to live on the planet. It's the mitochondria. It's the energy system in our body. All of our cells have these mitochondria except red blood cells, and they're turned over. But as long as we keep lung healthy, brain healthy, gut healthy, what means healthy? It means your mitochondria and those cells are healthy. How do you get them healthy? You have them burn ketones. How do you burn the ketones? Get into nutritional ketosis. But then you say, what do I have to do? Don't eat a lot of highly processed carbohydrates. Well, I don't know if I can do that.
Yeah, this is the hard part.
Then it becomes your choice.
Yeah.
But at least you know what to do and how to do it. Yeah. It's no longer a mystery. The mystery is gone. We know what to do to keep ourselves healthy.
Yeah, but as you say, this is not the way it's being treated right now. And I do see why you would say this is a great tragedy.
Oh, yeah. Well, I think it's a tragedy of lack of knowledge. I think it's because sometimes the cancer patients are told, eat whatever you want. I've had people tell me a person weighs 300 pounds and they take a chemo and they're afraid he's going to lose too much weight on chemo. A guy weighs 300 pounds for Christ. I mean, what are you doing? You're worried about this guy because you're going to give him chemo, might lose some weight. When you do metabolic therapy, you do lose weight, but the issue is therapeutic weight loss. You can lose weight if you're poisoned, of course. You're vomiting, you have diarrhea. I mean, this is terrible. You're losing weight. Well,
this is what happens during chemo?
Yes. Oh, yeah. Why is he throwing up? Everybody's talking. Why does he have diarrhea all day? Why has he got headaches? Why can't he get out of bed? I mean, you're poisoning the poor guy. I mean, he's not going to look like he's...
Can you please elaborate more on how the chemo is treating the patients and why does it...
Well, you see what they have doxorubicin. They call it red devil. Makes you pee red, your eyeballs red, everything is red. It's poisoning your whole body, right? The cancer cells are dying, of course, too, but your normal cells are getting damaged. Your mitochondria and the normal cells are being damaged as the result of that. Why are you doing that? People go bald, right? You ever see these poor cancer patients? They're bald. Why are they bald? You got cancer cells growing in the hair follicles? No. So why did you go bald? It's just an adverse effect. Well, listen, when you do metabolic therapy, your hair does not fall out. It actually gets starts to look even better than it was before. Yeah. So we've seen so much remarkable turnaround. And then the people, well, there's no clinical trials. There's no clinical trials. I can't believe it. That's just an excuse. The science tells us what we need to know and how to do it. Why didn't you look at the science? Why do you not want to do a clinical trial on this? We don't know. We don't know what to do. Well, we know what to do. We'd be very happy to show you. And then they always come up with some other excuse. Yeah. We can't do that because you're threatening their meal ticket on a lot of this. So you got to be careful. But we know what to do. We know how to do it. We have been publishing these papers. People will have to come and read. They're open access. You don't have to go to a library. You get it right off the web.
Yeah, but this is very proactive on the patient side or the general public. Yeah.
Well, I feel bad for so many patients. They run down to their top, whether it's in Israel or Boston or New York City or California, they run to their top medical schools. Now, don't get me wrong. We have made major advances in medicine for heart health. Our orthopedic people have remarkable, hip replacements, knee replacements, all kinds of unbelievable advances in almost many fields except cancer. We're still in the Stone Age with respect to cancer.
Yeah.
So you don't do this if you understand the nature of the disease. And I'm not speaking as if I'm the one who started all this. Otto Warburg, the great German scientist, knew what cancer was a metabolic disease. But we found out where he made mistakes and where he didn't have certain information that we now have. So I went back and I was able to clearly see what Dr. Warburg had done, and I found out where he made big mistakes and where the field continues to make these mistakes. And we've published papers showing how these mistakes have been identified. Now you can deal with them. And Warburg never developed a therapy, a successful therapy based on what he had discovered. We have done that now with the press pulse metabolic therapy. We have now developed real logical ways to manage cancer based on our understanding of the science.
Can you just elaborate? What did he won the Nobel Prize, right, for something he
he won the Nobel Prize for his discovery of the respiratory enzyme, which is basically cytochrome C. And he was nominated many other times. He's also an interesting figure for history's sake because he was half Jewish, and Hitler spared him. Because Hitler felt that if anybody was going to cure cancer, it would be Otto Warburg. Oh. So why should, and there was a lot of animosity after the Second World War because of that. But believe me, he was no fan of the Third Reich or Hitler. So he just wanted to continue to do his research. And he was nominated, but Hitler didn't let Jews, or any German, I should say, receive Nobel Prizes during the Second World War. But he was nominated so many times for his work, but he only received one. And then, of course, after the war, when Watson and Crick found the structure, or at least defined the structure of DNA, the field ran off like lemmings over the cliff, following the molecular biology, finding abnormalities in the structure of DNA in tumors, thereby saying, oh, yes, look at all the mutations in tumor cells. And we've been chasing that tail for the last 70 years.
Yeah.
And it has
the genetic tail.
Yeah, the genetic tail. And we have more dead cancer patients today than we've ever had. So obviously it's not working. Yeah. There's millions of mutation damage. And we find tumors now that some tumors have no mutations, so how are you going to target something that's not there? And now we're finding that these driver genes, they said, only some genes are really bad. They're called driver genes, KRAS, and all this kind of stuff. And we're finding these in normal cells of our body that have no dysregulated cell growth. So this is another problem. And then, of course, what I did is I went back and looked at all these nuclear mitochondrial transfer experiments, where completely showed that cancer cannot be a genetic disease. I mean, you have to be cognitively challenged when you actually look at the data to think that this is a genetic disease. And yet the field continues to push this stuff. And we get dead people. The result of that are brutalized people that are poisoned and treated terribly for the failure of the field to recognize what I'm saying. And if they don't believe me, read what part of the equation do you not understand? What part of the hard science do you not believe? Because I'd like to know. We've been trying to figure it out. We don't see any major challenge to the science. Wow. We just see it from conceptual belief systems. And you see when the patient goes to the oncologist, they'll say, eat whatever you want. Glucose has nothing to do with cancer. What are you, crazy? I mean, we have dozens and dozens of human experiments, animal experiments. The higher your blood sugar, the faster the tumor grows.
Yeah.
You got to keep the blood sugar down, and you got to target the amino acids and keep the ketones up so your normal cells start to get really healthy. So it's a combination of keeping your normal cells healthy and slowly degrading these inefficient tumor cells. And they say, well, tumors are very flexible. They're not flexible. All these gene mutations, they have prevent flexibility. They're locked into a fermentation metabolism. They can't choose. We interrogated the tumor cells asking, what can they live on? We just found out glucose and glutamine. They can't live on anything else.
Yeah.
So simple. And the cancer cells have been telling us this for decades. Our scientific studies show that all these tumors are throwing out lactic acid and succinic acid. These are the metabolic waste products of glucose and glutamine metabolism. And the cancer cells are throwing it out, telling us, this is what I'm using, this is what I'm using. And you choose not to target what I'm using, and you have, it's just nuts.
Yeah.
So we have all the suffering.
Yeah. First of all, before I go into another matter, I hear in what you're saying right now. Can you please elaborate on the scale of the issue in America? Because as you said, in China, it's going like...
Well, it's all countries. I don't think it's just... I think the Chinese, I think in India now, all the countries are having the same problem. It's not just the United States.
As well in America?
Everywhere. It's everywhere. It's all over the world that cancer is increasing in all the countries. I mean, you look at we just published a paper just recently in the journal Oncology showing all the different arises in cancer, different kinds of cancers. We've made no major advance in lung cancer, pancreatic cancer, glioblastoma. We have made some small advances in some of these rare blood cancers. But for the most part, we have not made any major cancer. Once you hit a stage 4, they've been calling that for decades, you're considered terminal. What do you, give me a break? Well, we see all these we're all terminal to some degree. Well, somebody says, oh, he's terminal. Well, he's been out 10 years. When do you think? Of course he's going to be terminal. He's going to die someday, but maybe not from cancer.
Yeah. But is it all the types of cancer? Or is it?
Yeah, we can't find a tumor that doesn't require glucose and glutamine. So they're all the same, very similar. Okay, their mitochondria are defective, therefore they must ferment. If their mitochondria are defective, they must ferment. What do they ferment? They ferment glucose and they ferment the amino acid glutamine. So we have shown that. They don't respire. We have now shown there are 3 sources of energy in our body. We have glycolysis, a fermentation mechanism in the cytoplasm of the cell. It's called cytosolic substrate level phosphorylation, which is the glycolytic pathway. In normal cells, it produces a very little amount of energy, but in the cancer cell, it can produce more. We have oxidative phosphorylation, which is you and I are breathing. Most of our energy is coming from the fact that we're bringing in oxygen. Our cells are making energy highly efficient with the waste product of water and CO2. I breathe oxygen, I exhale CO2 and water vapor. So this is the waste product of normal oxidative phosphorylation. But our big discovery, working with Dr. Christos Xenopoulos from Semmelweis University in Budapest, world leader on mitochondrial substrate level phosphorylation. This is something that's always existed, but it was never recognized in cancer, where the glutamine is fermented inside the mitochondria in the absence of oxygen. So the mitochondria can still produce energy without oxygen through a fermentation mechanism. It's called mitochondrial substrate level phosphorylation. Warburg did not know about this. As a matter of fact, most people in the cancer field have no clue about this. So that's why they keep doing stupid things. They need to understand the scientific literature. Once you understand the scientific literature, the solution is right there in your face.
But I thought, perhaps I'm mistaken, but lung cancer is the most deaths are caused by lung cancer. Am I correct?
Well, people smoke. And they have living lousy air, right? They're going to get lung cancer.
My grandfather died from lung cancer. So
but we know they're fermenting. Okay, so let me tell you something. If people have a heart attack, right, you stop breathing. And if you fall down, if you don't breathe within 5 minutes, you're going to be dead because your brain is going to die from the lack of oxygen. Okay, but your bloodstream immediately fills up with lactic acid and succinic acid. These are your bloodstream fills up with this because in order to remain alive, you have to have energy, ATP. Our bodies can make energy to ATP through absence of oxygen through what we call fermentation pathways. As I said, one is in the cytoplasm and the other one is in the mitochondria itself. The waste products of glutamine, amino acid fermentation, is succinic acid. The waste product of glucose fermentation is lactic acid. Okay, so the bloodstream fills up with lactic acid and succinic acid in the absence of oxygen. Okay, as soon as you breathe, these two go down. So you're starting to respire again. Cancer cells, even in the presence of oxygen, still make the waste products of cytosolic and mitochondrial fermentation. That means we know what's going on. Their mitochondria are defective. They have insufficient ability to make energy through respiration. So they're constantly fermenting. So what are they fermenting? The glutamine and the glucose. Well, how do you kill cancer cells? You must take away the fermentable fuels. They can't respire ketone bodies or fatty acids. They collect them in the cytoplasm as big lipid droplets. This is not a complicated problem. People say, oh, it's the biggest problem. The cells have been telling us for decades. It's just that nobody understood what they were telling us, or like in a foreign language or something.
Yeah, the public likes to be led, but perhaps the medical
the
industry...
scientists need to be led. The scientists themselves, they've been collecting the data and not seeing it. They say, oh, these cancer cells, we all know they throw out tremendous amount of lactic acid and succinic acid. And as I said, that causes acidification of the tumor microenvironment. It's like the tumor puts a protective shield around itself from all the acidity. Well, where's the acidity coming from? Glucose and glutamine. So you take away glucose and no more acidity. Now you can come in and kill these guys with minimal doses of drugs or radiation or any of this kind. And you can shrink it down. I mean, we have so many unbelievable ways to kill cancer cells without toxicity. We don't need to be doing the crazy stuff that we're doing.
This is incredible, and I really hope some people with power in this field might listen and do what.
Well, we'll see what happens. You know, my research is run on philanthropy and private foundations, and you'd think we'd have hundreds of millions of dollars because we have the solution to the cancer problem, and they say, "Oh no, that can't be right."
Wow. Yeah,
I says, go look at the data. You tell me where we made a mistake. Go back and look at Otto Warburg's results. I mean, he was a giant in the field. I mean, we're just following his path, except we've now cleared away a lot of the brush.
As you said, I think the status quo, people really don't want it to change most of the time. And I do think that when I think logically about the motivations of some of the, as you said, big pharma perhaps, but also even, Coca-Cola or the most, they wouldn't want
this is another thing. We're never going to tell anybody, don't drink Coke, don't eat a Twinkie, don't eat pizza. They will have to come to know for themselves when they look at their own physiological glucose-ketone index.
No, but what I'm saying is perhaps the owners of those companies don't want this data to be out in the public.
Well, they're kind of changing a little bit. They're making more and more healthy drinks.
Yeah.
I mean, they are starting to respond in certain ways. You want to be some level of responsible. You don't want to be recognized as a company or something that's immoral, to keep pushing. And that's another thing that gets me really upset is, everybody knows we have a toxicity, physical toxicity associated with these poisonous chemicals. But there's also another form of toxicity called financial toxicity. People who are living, paycheck to paycheck, they don't have much money to pay for all these expensive drugs and things. And then if they die, they're destitute. They've lost all their savings. Marriages fall apart. Some people commit suicide because they can't afford the cost of the treatments that they had. And sometimes these bills are passed on to their surviving loved ones. I mean, this is immoral.
Yeah.
I mean, there's a different thing about people being unethical, but you can have immorality. And financial toxicity is caused by a system that's immoral to its core.
Yeah,
So you shouldn't have this, and you shouldn't be paying for something that doesn't work. If you're paying $55,000 for a treatment and you end up dying, you should get your money back. Oh no, we can't do that.
Yeah, usually the lower classes of people are
Yes, well,
suffering
they're
from
the people that suffer the most.
Yeah.
But, the problem is the rich people also get hammered. They go to the top medical schools that they're getting the best. And they end up sometimes dying faster than the poor guy who can't afford it.
Well, you use the word making me upset.
Yeah.
You seem to take this whole matter very personally. Is there?
Well,
a reason?
I see it. I see it. I had a student that did a big report on financial toxicity. He was in the economics department here at Boston College, and I couldn't believe what he was showing. Lumistan, it's a drug that really didn't know it had much use in cancer, and it was a cheap drug, like $3 a tablet. As soon as they found out that it could have an effect on cancer, it was like $800 a tablet. I mean, this is immoral. You don't do stupid things like this. So, and yet we're doing it over and over again. I'm sure some of these companies they may have a modicum of morality, but I don't see it for what we're doing. Why are we charging so much money for cancer treatments? This is nuts. I mean, you can kill those tumor cells just by bringing your body into a low GKI and then coming in with what we found is the parasite medication, embendazole. There's plenty of papers on that, fenbendazole. They seem to be very effective when you're in nutritional ketosis. Everything works better in nutritional ketosis. We can move drugs across the blood-brain barrier so much more easy. We have evidence, mass spec analysis showing that these drugs to kill brain tumors can go right through the blood-brain barrier when you're in a state of nutritional ketosis. I mean, we have all of this evidence, but it doesn't seem to be. It doesn't seem to be igniting in the field.
And this is what upsets you the most.
Yeah, it gets me upset from many different reasons because I see human suffering at a grand scale, not only in the United States. I see it everywhere, and if I see people that are bald, I see people with swollen faces from high dose steroids. You get called moon face. Okay, steroids are anti-inflammatory, but they raise your blood sugar very, very high. Why would you give anybody something that's going to make their sugar that the tumor is going to feed upon, right? And then they die. It's not like, you look at the tragedy, they're bald. It's just like, what's human suffering that we have for a disease that's not as complicated as people made it out to be, because they think it's a genetic disease. And when you think it's a genetic disease, it's hopelessly complicated. It's hopelessly complicated. And therefore, we target this and target that. We have to spend a lot of money. It can't live without the sugar, glucose, and the amino acid glutamine. It's not as complicated as people make it out to be. Prove me wrong. That's what I say. And when we have people that are saying, let me get into low GKI, and we come in with the parasite medications or even small doses of chemo, all of a sudden they feel good. The tumor's been managed. I don't know how long they're going to live, but there certainly doesn't look like they're going to die anytime soon. And the other thing the field does, especially in the United States, the National Cancer Institute, they say on their website it's a genetic disease. Can you believe this? I mean, they say right on the website, cancer is a genetic disease. I said, what, are you kidding me? And then they say, we have to keep putting large amounts of money into cancer research. Listen, the more money we spend on cancer research, the more cancer we get. There's no question. Every year, the numbers of dead people come up.
Why is that? Why is this?
Because we're not targeting the right things. We're not managing the disease as it should be managed.
But if we spend more, we are expanding the disease itself?
We're not expanding the disease. We're allowing the disease to continue to get worse. You're not doing anything to drop the numbers, because you're not targeting the right thing. So cancer is getting worse and worse in our society because we're in an environment that's contributing to cancer. Okay, no exercise, highly carbohydrate processed foods, right? A lot of emotional stress. All of these things are contributing to the gradual rise in cancer. So when the National Cancer Institute in the United States says, we've made tremendous progress, 33%, that was from people stop smoking. It's a prevention. What are you telling me, new drugs? New drugs aren't doing that. It's the personal choice of people managing their own condition. We stopped smoking. It became unfashionable now to smoke. Yeah. Remember, years ago in the scientific meetings, you had to move the smoke out of the way so you could see the screen. Then they say, you can't do that. Restaurants you can't smoke it. Now they see somebody smoking on the street, they come after you and they grab you. So cancer death rates went down by 33%, and they're trying to tell us this was all the new drugs. This is nonsense. Wow. This is nonsense.
And if I may, what's the thing that got you into going down this field? And
well, it's when I wasn't like this when I first started saying all this kind of stuff, because now I have the scientific evidence to say it. Yeah. I didn't have the scientific evidence before. I was collecting it gradually. So we were looking at work in the field of epilepsy, where I knew ketogenic metabolic therapy could manage epileptic seizures. And we had some beautiful models and people and all kinds of little children doing metabolic keto, and their seizures were being managed. And I said, wow. But then we started to do just any diet calorie restricted was lowering blood sugar and elevating ketones to the same degree. And we got the management of the seizures. And then we were doing cancer, and for a different reason, just looking at biochemistry. We started putting them on these diets. Oh my God, these tumors are like not disappearing, but certainly getting less inflamed, fewer abnormal blood vessels. Tumor cells were dying through mechanisms, apoptosis and ferroptosis and every kind of apoptosis you can think of, and they were dying. I said, wow, this is really interesting. And then I came across Otto Warburg's work. And then I said, is this guy right or wrong? And we started to show that he was right, but he made certain mistakes. He didn't know about mitochondrial substrate level phosphorylation. That's our big thing. He made the assumption that cancer cells consuming oxygen produced the same amount of energy as a normal cell consuming. No, we and others, that cancer cell consumes oxygen, but it doesn't make energy. It makes ROS, reactive oxygen species, which cause the mutations in the nucleus that the field is chasing. So the field is chasing downstream effects of abnormal mitochondrial metabolism, making new drug, looking to target that. It's all downstream effects. That's why we're not dropping the death rate. So they're chasing tails. They're not chasing the origin.
Yeah, I get it totally. But if I'm hearing in your answer that it's the results of your research that got you into the enthusiasm of fixing it.
As a scientist, we collect data, we analyze the data, and then we start to design experiments to test our ideas. And I'm starting to see a lot of things that Otto Warburg said. I'm seeing the same stuff. And then of course we pulled the mitochondria out of cells. Okay, we isolated and purified mitochondria out of the tumor cells and normal cells. And there's a very important lipid called cardiolipin. It's an incredibly interesting lipid in the inner membrane of the mitochondria that allows the efficiency of oxidative phosphorylation. When you and I are breathing right now, we're making anywhere from 32 to 38 molecules of ATP in the cells of our body. That efficiency comes from the structure of this lipid. It makes the proteins of the electron transport chain work very, very efficiently. We found that lipid was damaged in all the different cancers that we looked at. The cardiolipin was abnormal. Therefore, the efficiency of oxidative phosphorylation is going to be abnormal. And when you look at the mitochondria under the electron microscope, the cristae, the beautiful stripes and intermembrane folds, are abnormal in many ways. Structure determines function. We know that as a biological principle. Structure determines function, which everybody here in the biology department at Boston College would know about it, except in the oncology field. They seem to not know that structure. They look at a bad mitochondria and they say, oh, it's taking in oxygen just like normal. It can't be bad. Well, are you kidding me? It's bad, man. The oxygen is not going to ATP. Where are they getting their energy from? Fermentation. What are they fermenting? Glucose and glutamine. How do you know? Because I see the crap waste products that the cancer cell is throwing out.
Yeah. So
and when you kill them, lactic acid and succinic acid go away, the damn cancer cell dies.
Yeah. So you see it literally in your research.
Oh yeah, we published papers. You can see the tumor cells dying. You can see them dying. And even the mouse and then the human, I mean, what happened to your tumor? We had a guy the other day from one of the clinics that we worked with had surgery. He was scheduled to have a surgical debulking of a tumor in his colon that was obstructing the colon. My colleagues put him on a very strict metabolic diet. Let's put it this way, getting his GKI very low and then hitting him with some parasite, and he went in. The surgeon says, well, there's nothing to remove. To cancel the surgery. And they said, what happened? Hocus pocus, where did this thing go? It disappeared because you pulled the plug on the fuels that it was using to grow.
Yeah, I totally get it. Do you get pushback from the scientific community?
It's not a pushback. They ignore it pretty much.
They ignore it.
Yeah, well, that's always what they do. Whenever you have a major change in the way you think, that people don't want to look at it, they don't want to talk about it, they don't want to hear about it, and then they always come up with, he didn't do that, or he didn't do this. Well, what didn't he do? Tell me what he did.
How can someone ignore a research which is based on
they
data?
do. Oh, it's absolutely clear. I mean, this has been done. You can go back and look at the different paradigm changes. The movement of the Earth to replace having the Earth replaced by the sun. This is called the heliocentric theory. For 1,800 years, our members of our species thought that the Earth was the center of the solar system, until Copernicus, Galileo, and Kepler kind of figured that out, and poor Giordano Bruno, the mystic, the Roman Catholic mystic, who thought Copernicus might be right. The Catholic Church burned him in Plaza Fiori. I mean, because it was challenging a worldview of what it's supposed to be. And when you challenge views of what's supposed to be, you oftentimes have a kickback. Same thing with Louis Pasteur's. He was vilified by the French medical aristocracy for what he was saying. Same thing with Darwin Wallace's theory of evolution. As opposed to special creation. I mean, these guys are still vilified today.
Yeah.
So these are major paradigm changes. And today we're dealing with the somatic mutation theory currently being viewed, but it's the mitochondrial metabolic theory, which is really telling us what cancer is and many other chronic disease. It's a disorder of mitochondrial biology. That's what it is. We should be focusing on that, not on all this crazy stuff that we're doing.
But do you feel like you're someone like Galileo or something like that? I with all humility, of course.
Yeah, all humility, more power, more, because we're going to save millions of lives. It didn't. Your life wasn't depending on whether you thought the Earth was in the center of the solar system, right?
Yeah.
Right.
No, but do you feel...
your life didn't depend on whether our genetic our arrangement of genes in the nucleus were similar in a mouse and a human. I mean, but today we're dealing with a terrible disease, allowing so many people to die needlessly. All right, there's some value to that, knowing that you don't have to do that, and that means the paradigm has to change to realize this is a mitochondrial metabolic disorder. That is a paradigm shift of the enormous proportion, and it's also spills over to dementia. Diabetes, cardiovascular disease. You can go right down the list.
But do you feel like there's something about being the person who is in charge of making the paradigm being shifted, that perhaps you're getting something... do you pay a price? This is what I'm asking.
I don't know. I'm still doing my research. What price? You're right. Are we right with all the minutia details? No. But that once the medical profession realizes what I'm talking about, and they start to say, let's focus. Oh, we're going to streamline these cancer treatments very, very effectively. We're just not focusing on the right thing. We're still chasing genes. Israel government, American government, we're chasing mutations. Yeah. The mutations are all downstream effects. They're not the cause, they're the effect. So how are we going to manage the disease if we're chasing effects?
It sounds amazing. How positive are you that it possibly will change in our lifetime?
It has to change.
It has
to. What do you think? Everybody would love to die of cancer? No. And we have a solution to this problem, and we have the science to support it. And the problem is the system as it's currently structured is so powerful. It's an extremely powerful system, right? But we have to do it gradually. We can't flip the whole system overnight because it would have too much disruption. It has to be a hybrid system. So you have to know that your poisonous drugs, your radiation, and all these things will work much better if your patients are in nutritional ketosis. The doctors have to know that. And they need to say, and the patients have to collect the data to let the physicians know they're in nutritional ketosis. Mm-hmm. Now we can use hyperbaric oxygen as a replacement for radiation therapy, or because it kills by the similar mechanism, but it only works if your patient is in nutritional ketosis. Otherwise, it doesn't work.
Yeah.
So all of these drugs will work so much better. And it might be a little bit of sacrifice on the part of the patient, right? The patient's going to have to be a participant. They have to be in control of their destiny. They have to have, I tell you, when I talk to some people who never had a college degree, and I tell them, you better start learning this. They learn it real quick. You can't believe when your life is online, how smart people can become in a very short period of time. I better know what this guy's talking about if I want to stay alive. Yeah. And then they get their themselves into low GKI, and then they can take drugs. This is what our clinic over in Istanbul, Turkey is doing. They're getting people into these ketotic states and then giving them a chemo. But it's a low dose. It's not like a super high dose. So, and it works better for brain cancer, colon cancer. It works better for all these different cancers.
Wow, I really hope that if I may, I don't know if it's appropriate to say, but I hope you see this change happen in your lifetime.
Well, if it doesn't happen in my lifetime, it will happen sometime in somebody's life. People want to stay alive and stay healthy.
I hope I will see it in my lifetime, perhaps.
Oh yeah, you're young. Yeah, so, but it's going to change. Has to.
I hope so.
Because it can't continue on this based on an incorrect theory. It's like still believing that the Earth is the center of the solar system. It's not that anymore.
Yeah, the thing about myths, I think there are some more, and I wanted to ask you about it because.
What I already met. The key is no exercise, very little exercise. That's not a myth. Obesity, obesity is replacing smoking as a but obesity is often linked to high inflammation, systemic inflammation. Okay, so we published a paper just recently. I expanded now. All of the things called the oncogenic paradox, all of the things that can elicit chronic disruption of mitochondrial function. Okay, so we have chemical carcinogens, and now we have these forever chemicals that are in our environment. Yes, they can get into the mitochondria, disrupt oxidative phosphorylation, leading to a replacement of substrate level phosphorylation. Radiation, of course, everybody knew that. Intermittent hypoxia, interesting. This is what Warburg said, and it's been repeated. So some people at night, they have sleep apnea. They stop breathing for long periods of time. Right? Maybe a minute or 30 seconds or something like this. And that damages mitochondria in some tissue. Once that mitochondria becomes damaged, the cell either dies or it slowly, gradually starts to transition to using fermentation energy, driven by oncogenes, which open the floodgates for glucose and glutamine to get into the cell. You put new mitochondria, those things shut right off. And what else do we have? Oh, we just have a big paper just come out now in the journal Oncology. All of the inherited mutations that are cancer linked, like the Li-Fraumeni, the BRCA, the women breast cancer, we have a variety of others, the Lynch syndrome and all these. We found out that every one of those inherited mutations damages in some way oxidative phosphorylation, reduces the efficiency, leading to substrate level phosphorylation and dysregulated cell growth. Yeah. And the cells start to become dysregulated in growth because the cells in our body are sitting there healthy and doing their job, right? Well, what makes them all of a sudden start to proliferate out of control, which is cancer, dysregulated cell growth, cell division out of control. What controls the differentiated state? The calcium currents and the energy of the mitochondria. The mitochondria determine whether your cells should divide or not. If we take a piece of your liver out, the liver will regenerate, replace the cells, but they know when to stop growing. Hepatoma continues to grow because the calcium currents inside the mitochondria control contact inhibition. The mitochondria control the destiny of our cells, when to divide, when not to divide, right? That's all controlled by the inner membrane of the mitochondria and calcium currents. The checkpoints of the cell cycle are controlled by calcium currents inside the mitochondria. So when that mitochondria becomes corrupted over time, the cell loses it starts going through it falls back on its ancient pathway of fermentation. This is the way all cells were on the planet before oxygen came into the atmosphere 2.5 billion years ago. Yeah. Those cells were growing and growing and growing. They had no mitochondria. They would die when the fermentable fuels disappeared. They would die. Cancer cells are doing the same thing. They're falling back on these ancient fermentation pathways driven by fermentation. What are they using? Glucose and glutamine. Take away glucose and what happens? They die.
But isn't it the cause of many years of
yes.
activities? Yeah.
Yeah. Okay. It doesn't happen overnight.
It doesn't happen overnight.
No. But the cell struggles. It struggles to maintain oxidative phosphorylation because that is the destiny of the cell. Okay. And when that gradually, slowly, from reactive oxygen species, chemicals in the environment, intermittent hypoxia, systemic inflammation, any of these or combinations of these will chronically damage the ability of that cell in a particular organ. To some of them will die for sure, but the ones that survive seem to be shifting to this fermentation ancient pathway.
Yeah, but if so, you can look at someone's diet or someone's activities, and you can say that he might in a couple of years.
That's why we developed the chart. So if you're in the red zone all the time, that dark red zone, high GKI, like 100 or above, you're putting your body, you're abusing certain cells in your body. It's only a matter of time before you have maybe cancer, diabetes, other kinds of chronic diseases. Cancer is just one type of mitochondrial dysfunction. You can have any one of these. Dementia. You don't wake up one day and you're demented. Dementia happens over a course of time, right?
Oh, so is it fair to say that foods you are eating in your 30s perhaps will meet you at your 60s with dementia?
Yeah, well, if you're in the red zone for your 35 years, you're going to get something, right?
And it's a matter of time. You can't tell how much time, but you can.
Well, we don't know. See, right now, we've never had a tool. We've never known where we were. We enjoy what we're eating. We're slowly getting fat. We're slowly getting chronic diseases. We never had a tool to say, I've been in that zone, that bad zone for 5.5 years. No wonder I have what I have. But now that I know I'm in that zone, is there any way I can get out of it? Yeah. Well, now you know. And when you start to do it, like we tested it about a month ago here in the lab just to see. It took me 5 days to get down below 10, GKI below 10, which is a prevention zone. But I was eating, tomahawk ribeye steak, with sauce béarnaise on top of it. I was eating bacon and eggs. I was eating hamburger with sriracha on it, right? I was eating lamb chops. I wasn't eating bread.
During the whole time
every
of the day?
Every night, I would have something different for 5 days. But
Sounds amazing.
Yeah, but I didn't eat anything else. Maybe a handful of nuts, like some cashew. No, it wasn't cashew. It was almonds, walnuts, and pecans. Just a little bit of those. And then at night, you have a ribeye steak, with some melted butter on top.
Aren't you worried about cholesterol? Or is it,
no. What is that? Cholesterol is a myth. That's one of your myths. Yeah. If I were to eat like every night, like a pound, 2 pounds of meat, your body would be overstressed with so much. Okay. But if you're eating small amounts and you can skip a day or whatever, your body comes down as pristine. We're back in as Paleolithic man. We're back as Paleolithic man. He never had to worry about cholesterol and stuff. I mean, cholesterol is a myth. It comes with high sugar. Whenever you have the high sugar in your bloodstream, high fat, high sugar, you have all kinds of risk factors. But when you have low sugar and high fat or cholesterol, the sugar is the bad. The high blood sugar forces the cells to become abnormal. Okay, you start to create mitochondrial damage.
Yeah, and what was the result of your examination?
I got down from, I usually am around, in the 40s. Above 50 and above, you kind of push yourself out. But during the course of a day, like if you don't eat anything overnight, like you go 18 hours or 20 hours without eating, you can start to see, you start to see it falling. We have to, right now, we use the Keto Mojo. We take a blood, and you have a glucose strip, and then you have a ketone strip, and it measures the blood glucose and ketones, and the meter is there, and you push the button, and it gives you a ratio of glucose in millimolar, so you know what your ratio is. So, if you're down in the low zones now to manage cancer, to kill cancer, manage diabetes, you're down in the 2.0 or below. Excuse me, you're down at 2.0 or below. Like if you go on water-only fasting, that's tough to do. I mean, it's tough.
Yeah.
So what we're doing, we actually take people and put them on a zero-carb diet for about 10 or 15 days. And your body, your withdrawal, glucose withdrawal is a very powerful, because glucose is an addictive metabolite. Are you kidding me? They don't believe me? Try it and see what happens.
You feel it immediately.
You're not eating bread, potatoes, rice, pasta, and that stuff. All of a sudden you say, where's the cupcake? I need it. Right.
Yeah, but you also get sharp, right?
Yeah. Well, then when you're down in that zone, then if you do water-only fasting, it's the small jump now. It's not so traumatic. If you're eating high carb and then say the next day I'm not going to eat any food for 3 days, Oh, it's hard. Your body goes through a withdrawal. It's like very difficult. So we gradually take the cancer patients and we move them into this low zone. And then when they're down in the zone, then we come in with all of the targeting to hammer out to hammer the survivors out.
Yeah, this is fascinating. It's so. Thank you so much for all the detailed explanations. Yeah.
That's all I do.
Yeah,
that's what I do.
So I wanted to give a little bit of zoom out, perhaps. If someone wanted to prevent himself from or herself from getting cancer or any of those metabolic diseases, what should be their diet? But well,
again, it says anything that will keep you into a GKI zone. We call it the yellow zone. So prevention would probably be between 25, 10 and 25. My good friend Dominic D'Agostino from the University of Florida, he's a modern Paleolithic man. He's always in one of these zones. He's eating eggs and he doesn't eat any carbohydrates. He's pretty much just like our ancestor, right? Where would the ancestor? Where would our paleo get a jelly-filled donut? Where would he get a glazed donut? Or big chocolate chip cupcake? They didn't exist.
I wonder how they would react to such thing. Whoa.
Oh. Yeah. You just think about it.
Wow.
They would be tearing each other's arms off again.
Yeah, they never seen anything like that at all. Yeah. Not to mention social media.
Oh my God. Well, it's like giving somebody a drug, an elixir.
Yeah.
All of a sudden your brain gets like, oh my God. It's like I just shot myself up with something I've never experienced before. But now we know too much of it too often can put us at risk for all of these different chronic diseases. That's why knowledge is power. You have to know that's why we had feasts to enjoy occasionally being in one of these happy zones, because most of the time we were living a miserable existence.
Yeah. So, but if someone isn't measuring daily,
once the paper comes out, it's going to come out next year probably. It's under review. It's called the Glucose-Ketone Index, a quantitative tool for managing cancer and other chronic diseases. Everybody will have the tool available to them, either with continuous glucose-ketone monitors or pricking finger. But you will have the ability to know at any given moment where you are with respect to your overall health.
And you think it's like individualistic?
Absolutely.
Absolutely. There's no generalization.
No. Most of the time, it's very individual. Like what would work for you may not work for me, for this young lady. The age differences, cultural differences. Some religions, they can't participate in doing some of these things. But we can design foods around those religions, those cultures. So it becomes very individualistic.
Yeah.
And that makes it usable. That makes it usable by almost everyone. So and it's their choice. They don't have to. They don't need to do it. I mean, but if they want to know it, and they want to improve their health, even in a very toxic environment that we live in, as long as you know you're in these zones, your mitochondria will be healthier.
Yeah, and this is why you are reluctant to give general advice.
Yeah, I don't give any advice.
Yeah.
So I just say, let the machine, let your body tell you the advice. Your body is not going to lie to you. It's telling you this ain't a good zone to be in.
And there isn't too soon of an age to do these measurements.
No, I mean, we were doing metabolic therapy on little kids with epilepsy. So we know one of the great tragedies was have a pediatric oncology. I just get so upset when I see these little children being irradiated and poisoned with the big fat swollen faces and the brain damage that goes through this. This doesn't have to happen. This is crazy stuff. I mean, we have some evidence now where in pediatric models of brain cancer that we're seeing some really, really spectacular results. We're not using it because they think cancer is a genetic disease, so they keep doing horrible things to these little kids. And it doesn't have to happen. Even adults with glioblastoma, which is a deadly brain tumor, very, very poor survival. We clearly showed that when you irradiate the brain, you free up massive amounts of glucose and glutamine in the brain. Well, that's the surviving tumor cells are going to be using that to grow very, very fast. And then you give high-dose steroids to reduce the swelling from the radiation, and you raise the blood sugar, and they die. So it's like unbelievable how every major hospital, the survival for glioblastoma follows the same track. This has been going on for 100 years, and they've done nothing to stop it. And we know how to stop it, and they won't not do this. Yeah. I keep telling them, we'll do metabolic therapy after we finish standard of care. What, are you radiating poison the guy? And it never works most of the time. Not never, but rarely works. And now you want to do that, and then when it doesn't work, you're going to do metabolic. Why don't you do metabolic? Oh no, you can't do metabolic up front. Why? Because God forbid it works.
Yeah.
You won't need the radiation. Are you kidding me?
Yeah.
People are making a lot of money irradiating the brains of somebody else.
Yeah, we're laughing, but this is.
Oh, I know. I mean, it's tragic. It's hard. Yeah. I mean, you have to look at the absurdity, the absolute absurdity of our species in doing what we do for reasons that are unconnected to the overall outcome of the patient.
I think if it will come from some place, it will come from here. And
I don't know. It will come from our work for sure.
Yeah.
But, people will modify it, and I don't mind that. All you want to know is that you were right. Like, can you drop the death rate? Can you keep people alive on the planet a lot longer with a lot higher quality of life? And the answer is yes, if you do what we say and how we do it. Will it work for everybody? No. Will it work for the majority of people? Absolutely.
Well, yeah, I wanted to ask you, first of all, what is the future for your research? And after the study comes out and you say everything will work with the measurement device and everything?
Yeah, well, I think the future is continuing to do what we do. We have the best preclinical systems for evaluating and troubleshooting the different combinations of what we do. Physicians in the clinic like to know that what they're giving their patients has been at least evaluated in a preclinical model system so that they don't have this fear that, gee, if I kill the patient, or what's going to happen. You guys tested it? Yeah. So we know there are certain ranges that would be most optimal. How do you do the doses, timing, and scheduling so that when we push it into the clinic, we have to know how to adjust doses, timing, and scheduling from the preclinical system to the human. So that's why we started a new society called International Society of Metabolic Oncology. So we have people from all major continents, most of the major countries, that really want to get involved with this. And they all asking, how do we set up clinics in our hospitals and that we can start to implement metabolic therapy. And we wrote a big treatment protocol from our lab here, a very detailed treatment protocol for glioblastoma, brain cancer, published it in a major journal. And of course, what kills us is we published how to manage brain cancer, all of the things you need to know. And then the big brain cancer societies just came out with a paper ignoring everything that we said.
How do you explain that?
I don't know how to explain it. Either they don't have they don't know what they're doing, and they keep we have this new vaccine or something like that, and it's the same old. It's not going to work, man. Get over it. I don't know. I gave lectures. It's almost like you're talking to a bunch of plug sockets on the wall. They don't. It's like, they're not living. I don't know what they think or what they do. And you get up, they get up, and they walk away, and they do the same thing after I just told them what I'm telling you. So it's just like, what is going on in their brains? But I think it's the system. They're so locked into doing what they've been told to do. And this is what everybody is doing. You're doing that? Yeah, I'm doing that. Okay, we got to keep doing that. But this guy over here says we shouldn't be doing that. He doesn't know what he's talking about. No, well, what part of the data don't you understand? This is what kills me.
Yeah, but in their critics, do they address the data, or they just ignore it?
They ignore it.
They don't give any other.
I can't believe how many people in oncology never heard of Otto Warburg, never heard that cancer cells are dependent on glucose and glutamine. Never heard of it. They never heard of it. Whose fault is that? Is that their fault, or is it the fault of the training that they get? Right? The training, who designs the training for oncologists? Obviously, it's not somebody who understands the science. Otherwise, you wouldn't be doing this kind of crazy stuff. So how many layers of change do we have to have before? And then if we do have an oncologist, and we have many of them, realized in their mind, I know I shouldn't have done this. I know this is wrong. I know this doesn't work. But if I try to do something different, I'm going to lose my license. So they're locked into doing that by the system. The system locks them into doing things they know, some of these guys know that it's not right. So look at how many things you have to change. You have to re-educate the field. You have to completely show them that cancer is a mitochondrial metabolic disorder, not a genetic disorder. Well, how can that be when the National Cancer Institute awards millions and millions of dollars to scientists looking at gene expression profiles, hunting for gene mutation? This is nonsense. It hasn't worked. Look at all the people dying from cancer, and they're still chasing. And then we raise money, pink ribbon campaigns. The more money we raise for cancer research, the more dead cancer patients we get, right? Where does the money go? What are they doing with all this money? And what I'm talking about is not that expensive. We can manage the disease very effectively. Why are they chasing things that are, well, I never heard, you go, I never heard that glucose was involved in, what do you mean you don't know? Don't you read the scientific literature? Don't you know anything? So then they get angry and they get embarrassed and, it's this kind of thing. They get angry at me as if I'm the one bringing the messenger. I told you guys, this is what you need to do. No, it can't be. Because I would have, if it were true, I would have heard about it in medical school. I said, who's writing the curriculum for the medical schools?
Critical thinking is not.
It's not. That's not part of. You can't select people in some professions that are critical thinkers. They got to be doers, really smart guys that know what to do when they're told to do exactly.
We need them too.
We do. Oh, absolutely. I tell you, when the orthopedic surgery and all this, man, these guys are unbelievable. They're masters.
But okay. So your future is keep fighting the battle that you're fighting.
I just keep collecting.
When you're saying we do the work that we do, is just the same research, and you.
Well, we try to show that the phenomenon we try to find a cancer cell that doesn't need glucose and glutamine.
Oh.
Okay. Wow. That would be unbelievable. We haven't found one yet. So we have to go through all the tumor cells. We have to go through lung cancer, pancreatic cancer, colon cancer. We already done brain cancer. And then we have to show that when you target these fuels simultaneously and in a nutritionally ketotic state, you get really good results regardless of what the tumor is. And fortunately, I have so many people that contact me and I give them the information. And I'm seeing the positive effects in pancreatic cancer, colon cancer, breast cancer, bladder cancer, brain cancer, lung cancer, melanomas. We haven't found all the blood cancers, they respond really well. So we're seeing it across the board. It's just that, there hasn't been a clinical trial. I don't believe it until there's a clinical trial. Always tell me that. I said, well, what part of the data don't you? Oh, no, can't believe it. Listen, in the epilepsy field, they said, well, we don't believe keto-metabolic therapy could stop seizures because there's been no clinical trial. So they did a clinical trial, and it worked, and they still didn't believe it. There's no money in this kind of stuff. So when there's no money in it, people don't want to believe it.
But it seems...
but cancer is a different situation. Your life, it's your soul. Your very existence on the planet that's being compromised.
But the fact that you are trying to invalidate the thing, this is the scientific approach.
Yes. Well, I said, what part of the science do you... And don't forget, I'm resting on the shoulders of giants in the field. Albert Szent-Györgyi, Otto Warburg. These guys were on the right path. They were thrown under the bus, despite what their giant thinking.
So you hope someone will carry the load.
We are. And we're showing, actually, we've advanced it so much further. We've solved Szent-Györgyi's oncogenic paradox. He threw it out to the field in a very powerful paper in PNAS. Well, we can't figure out how can so many things in the environment cause cancer? What is the common pathophysiological mechanism that all these disparate things that might be causing cancer could cause cancer through a common pathway? We showed it. It was mitochondrial insufficiency of oxidative phosphorylation coupled to a compensatory substrate level phosphorylation, leading to abnormal calcium currents, leading to dysregulated cell growth, being fueled by ancient fermentation pathways. We showed it. And how do you prove it? You prove it if you really know what you're talking about. You take some person and you put them on metabolic therapy, and they're doing really, really well. That tells you know what the hell you're doing. And the quality of life improves. The overall survival improves. Over and over again, we see it, and we're publishing papers on it. Go ahead, look at the data. You tell me what's wrong about that. So the people have to say, whether they're in Israel, whether in the United States, Germany, France, we want metabolic therapy. The people, it's not going to come from your top medical schools. There's a very big resistance, but it's going to come from the people. The people have to hear what I am saying. They have to look at the papers themselves and discuss it with their family members and with an open-minded oncologist and say, I want metabolic therapy. Can you do it for me? Well, I'm sorry. Then we're going to go someplace where they know about it. And then a paradigm is going to shift. It's going to be a huge tipping point.
I really hope you're right and finding.
I am right. You're going to come to see it. You'll be alive long enough to see it. I might not be, but you will.
I hope so as well. Where can people find you, and how can people help you? And
well, I send the kit out of information to people. I only ask them if they want to make a donation to one of the foundations that supports our research. Most of them are poor people, and I don't expect anything, as long as what we give them can help them. I just need the money for the research. Money comes to our private foundations. It all goes to the research in the lab, or it comes to the university here itself. And so I can never accept any money personally. It has to come from the grants and the foundations. And then I employ the best people I can get to work on the evidence, the scientific evidence. And I work with clinicians to help them bring the information to their patients. So it's a whole global way of doing this. And the more and more people we train to understand this, the science, what has to be done, makes medicine the greatest excitement, because for the first time they're going to practice their art, knowing that they're going to see things and they're going to say, I know how to, this guy is of that size, this culture, this religion, I can work with him to make him have the best outcome. So it's going to be a wonderful way to practice medicine once you know what to do and how to do it. So people should be very excited about it.
Yeah.
Not only the physicians, but the patients themselves.
Yeah, I truly am. Okay, Thomas Seyfried, it was a real pleasure. I had a wonderful time talking to you. Thank you so much for coming to the show.
Thank you very much for the interview. Thank you.